Hi, ladies and gentlemen. This is Mr. Green. This is another in my series of recordings for Algebra 2. We're looking at 1.06, the factors of rational roots this time, and we're going to look at those. Remember, due dates are 28 days out. Please don't be late. I don't want things to get zeros on them, okay? So, factors and rational roots. What is a factor? Well, you can use synthetic division, just like we showed you in the last couple of lessons, to find out if something is a factor of a polynomial. And that's what we're going to do. We're going to start trying to factor some larger polynomials given some information. For any polynomial p of x, the binomial a minus x is a factor if and only if the value of p of a is equal to 0. So that means that if we get a 0 value, then we have a factor. And so we can use synthetic division to help us determine if something is a factor. Okay, so looking at this, I've got determine whether x plus 3 is a factor of something. So if I take x plus 3 equals 0, x equals negative 3. So I'm trying to determine if negative 3 is a factor of this particular equation. So I could say f of negative 3, or I could just do the synthetic division. So I'm going to do the synthetic division personally. 2, negative 11, 1, and 6. So put a 2 here. 2 times negative 3 gives me a negative 6. Add these, I get a negative 4. Negative 4 times negative 3 is 12. That adds together to give me a 1. 1 times negative 3 gives me a negative 3. That gives me a negative 2. Negative 2 times 6 gives me a positive 6. And 6 plus 6 is 12. And the answer is no. That is not a factor of it. Okay, got a sign wrong there. I'm sorry. Minus 6, minus 6. Okay, 3 times negative 2 gives me a 6. And that 6 plus negative 6 gives me a 0. So yes, it is a factor. Can you see how I got that 0 there? That is a factor. Now, just to show you that it does work, you could graph it on a graphing calculator and see if you get a factor, see if it does cross the x-axis at that point. Okay, so let's look at this one. X cubed minus 19x minus 3, given that x minus 5 is a factor. Well, we're supposed to factor the polynomial. You know, if I factor this 5 out, I might be able to see what the rest of the factors are. So I'm going to take 5 and I'm going to take x cubed minus 0 minus 19 minus 30. Where'd the 0 come from? Well, there is no x squared term in here. So I had to put a 0 in here. So I'm going to use synthetic division. 1, multiply by 5, add those together, get 5. 5 times 5 gives me 25. Minus 19 gives me a 6. 6 times 5 is, oh man, I must have something wrong there. Let's try this again. What am I looking? Oh, that's a 30. 6 times 5 is 30. That gives me a 0. So there it is. So there is my equation that I have left. Well, what that is x squared plus 5x plus 6. Well, you know what? I can see factors of that one. 3 and 2, x plus 2, and x plus 3 would be the factors there. And then we also have the 5 to begin with, so that was an x minus 5. So we actually have all 3 of the factors that we would be looking for in this particular situation. You can see how taking that 5 out of it allowed me to see what I could then factor. And that's why you can do these real easily, is by using that. Now, in case you don't know what an equation, what a factor is, this rational root theorem actually tells you that you can take p divided by q in its simple form is a rational root of the polynomial. It's telling you that q must be a factor of a sub 0. Okay? And that p must be a factor of a sub 0 and q must be a factor of a sub n. the highest order. So if you're looking at something, what you can do is take the coefficients of the terms, and each of those coefficients can then be, you can look at the factors of them, and what you'll be looking at is the a sub 0 divided by the a sub n. That means this is the constant term, and this is the highest order coefficient. Let me just give you an example here. Looking at this one, there's my constant term, 5. My factors of 5 are 1 and 5. I just a little factor tree there. My coefficient here is a 2. My factors of 2 are 1 and 2. So if I put these together as fractions, I say 1 over 1. Well, there's one factor. I could say 5 over 1. There's a factor. And then I could say 1 over 2. That could be a factor. And I could say 5 over 2. These are possible factors. They are not the actual factors. They're possible factors. Okay? Yeah, A sub n goes on bottom. Yes, that's the way it is. These are possible factors. So what are the possible factors? 1, 5, 1/2, and 5 over 2, which is 2.5. Those are possible. Okay? How would you determine if they're really factors? We could do synthetic division on them and see which ones turn out to be real factors. You do not have to just accept them as possible factors. You can see if they are real factors then by doing the synthetic division. So I appreciate the fact that you guys are sending me the fact that you're in Algebra 2. It really does help me find your records quickly and answer your questions. And that's what we're after to do, is make certain your questions get answered. I look forward to seeing you next time.